Hi there, I'm Brendan Burns. I'm one of the co-founders of the Kubernetes open source project and currently a corporate vice president of Microsoft Azure in charge of open source, Linux, cloud native applications, and DevOps for the Azure platform. And I'm here today to talk to you about how you can build portable services with Java, Kubernetes, and DAPR. Thanks for being here. But I want to tell you a story back before even before the world of Kubernetes, because my sort of software development career really started with Java, and my open source career started with Java as well. So my very first job out into the industry when I started out was working on Java server pages, the 0.8 release, I think it was, in the early days of the dynamic internet when we were, catting strings together in servlets to create web pages. And that led me also to my first open source project, which was the Apache JMeter project, which some of you may have used. It's a Java-based load balancer. It works for any programming language, but it's implemented in the Java programming language. It's a load tester for web applications. And I got involved with it because we were using it to test the application that we were building, needed some features. I went and contributed it out to this open source community, eventually added more stuff, and became involved as one of the maintainers. And that was really my first foray into building and developing software out in the open, and helping to lead an open source community. And in fact, my legacy in JMeter lives on, actually, because if you look, these icons right here that are used to sort of put together a test group are actually icons that I drew, sort of pixel by pixel, and you can see the purpley Java GUI, color scheme there that I used when I was doing that. So it's a legacy. You should be careful what you do out there, I guess, in the open source community, I guess, or anything really, because your legacy lives on for a long time after you've maybe moved away from the project. I moved away from the project in the early 2000s. So, but it was nice to go and see that when I was looking around at Apache JMeter. All right. And actually, you can run JMeter with Kubernetes now, so that's pretty cool too. It's kind of come full circle. If you want to use JMeter to do distributed load testing in Kubernetes, it's totally possible. So that's very cool. But I want to talk a little bit more about what Kubernetes has done, right? To sort of set the stage for what we're thinking about when we're thinking about building portable, reliable services on top of Kubernetes. At its core, Kubernetes is about automation. Right? Kubernetes is about taking tasks that would otherwise be performed by a human and automating those things for them, whether it's the act of deploying software from one version to the next, whether it's the act of restarting something if it happens to have failed, if it's the act of auto-scaling up either the containers or the pods in your application or even the nodes in your cluster. Kubernetes is all about automating all of these tasks so that you don't have to. Just like this robot here is making it easier for this person to accomplish their task by automating it, doing it over and over again. The guy who's programming this robot can walk away, go home, have a coffee, whatever it is, take the weekend off. And that robot is just going to keep on moving, right? And Kubernetes is the same way. Our applications are going to be continuing to move, continuing to be repaired, continuing to operate, even though we may be off, having a coffee or some other sort of beverage. And that's really fantastic, right? That takes a lot of load off of you. It makes it a lot easier to build reliable systems. And it also sort of allows for a lot of automation to drive Kubernetes, because the other thing that Kubernetes does is it is really API driven. And because it's so API driven, it's allowed people to build extensions both inside of Kubernetes, like things that can go and rotate certificates for you, things that can actually operate other pieces of software for you, the whole operator model that people have developed, or also that you can plug other things into it. So GitHub Actions, for example, can deploy to Kubernetes because Kubernetes has that API, and that allows you to automate, the workflow from source all the way deployed out to cloud. So Kubernetes has really done a number of things to help make it easier to operate reliable applications at scale. But the truth is that while Kubernetes is all about automation, developers are all about building stuff, right? And so they're about taking an idea from something that exists inside your head and taking it out to something that exists in the real world. And the honest to God truth is that Kubernetes does very little to help you build. Right? Docker came along and actually provided some pretty useful tools to help you build images, and that's pretty awesome. And Kubernetes has done a bunch to help make it easier for you to run those images, and that's pretty awesome too. But when it comes to the actual act of building a program, when it comes to the act of figuring out how to put the program together, how to connect it to other data sources, connect it to secrets, connect it to all sorts of different things, connect it to other services, Kubernetes really doesn't do much, right? And people have started to build some of these pieces, things like service meshes and things like that, have sort of started to fill in some of these details, but even a service mesh is really kind of on the outside of your program. It doesn't really do much to help you actually build the logic of your program itself. And if I cast my mind back to those early days of Java when I was doing Java servlet pages, all of that work eventually turned into things like J2EE, which was actually, despite all of the sort of large scale stuff that came afterwards, it was really about trying to take stuff and make it easier for a programmer to build a reliable application, right? And so I think that there was a lot of effort in that in the early days, pre-container days. I think containers came along and said, hey, you know what? We're going to give you this language abstract, language agnostic packaging format and build a lot of automation around deploying that and managing that, solve a whole bunch of problems in that space. And that's really fantastic, right? Because the whole act of managing VMs with shell scripts was just a bad idea, right? And so we've spent a lot of time improving the state of automation for running applications. But I think that's why we're seeing a trend now towards improving the state of building those applications. And DAPR is a part of that. And I want to sort of walk you through sort of the motivations and what DAPR is trying to do. So, but I think it's important to note that Kubernetes actually does help the developers a little bit, right? I don't think, it's not so bleak as to say like, well, we spent all this time doing ops automation and we totally ignored the developer. There is actually some characteristics that, we get from Kubernetes. And it's important, I will consider those things first so that we know sort of the space in which we're playing, right? So when we think about Java, when I was programming in Java back in the late 90s, one of the very most important things that people would say was this whole idea of write once, run anywhere, right? So Java would say, and I should have probably had a picture of Sun OS as well, Solaris up there as well, because actually the application that I was building in the early 90s, or sorry, the late 90s in my first job out of college was actually on Solaris. But Java's big promise was to say, hey, you know what? You can write this thing and it'll go anywhere. It'll go to Linux, it'll go to Solaris, it'll go to FreeBSD, it'll go to Windows. Write once, run anywhere, right? And that's actually really valuable, even though we found out that, of course, it's not 100% true. It was 85% true, and more importantly, it was true enough that it actually delivered value to people, right? You can share libraries across these platforms. You can share programs and experience across these platforms. You may have to tweak things a little bit, and especially in certain areas, you get tightly tied to a particular operating system. But there was real value here. And when we look at Kubernetes, Kubernetes is actually doing the same thing for clouds, right? And so what Kubernetes has come along and say, sort of like Java came along and said, hey, there's all these operating systems. We all want to write programs for all these operating systems. Kubernetes is saying, hey, look, you know what? There's all these clouds. Sometimes it's a private cloud. Sometimes it's a public cloud, like Azure. Sometimes it's bare metal, actually. And deploying into all those different environments, it's maybe hard to remember, casting your mind back, it was really complicated. There wasn't really a centralized format. There wasn't really a centralized way of representing things. If you wanted to plug CI/CD into it, you had to build special adapters. Kubernetes came along and said, no. Like, we need to provide this generalized abstraction layer so that everything in the applications that you're building, you can target any of these places. And that's really powerful, not just for people because they want to target multiple clouds, but actually because it sets the groundwork for collaborative innovation, right? If I'm building a really great library for building distributed systems, but it only targets Azure, well, then the only people who are going to come and work with me are people who are deploying stuff to Azure. And while that's a lot of people, it's certainly not the entire world. And similarly for other clouds or on-prem, that sort of sharding that happens, similarly to in operating systems, the sort of sharding that would happen if you're a Windows developer, a Linux developer, a FreeBSD developer, is bad for innovation, right? And we recognized this a long time ago in the sort of the days of the Unix wars in the 1980s, where the POSIX standard was developed to sort of allow developers to build applications across all of these different platforms. Kubernetes has always been envisioned by me and by others as the POSIX for the cloud, right? So it's been envisioned as this shared runtime that allows programs to go everywhere, but also that allows us to innovate and build libraries and utilities that are useful to people no matter where they're deploying their cloud. no matter where they're deploying their code. And that's hugely valuable because it means we can all come together as a global community and we can collaborate and build tooling that helps advance the state of the art. But is that enough? I don't actually think it is, right? It has provided the groundwork for us to come together, but we actually need the projects. We actually need the ideas, the shared library, if you will. So if you imagine that Kubernetes is sort of the JVM, the Java virtual machine that allows you to write applications that are portable across all of these different cloud environments, we still need a standard library, right? So without the standard library, without all those classes that come with Java, Java's a lot less useful. It's useful still. I mean, your code will still run in multiple places, but you're going to spend a lot of time writing code that you really should be sort of inheriting from someone else's implementation, right? And I think Java is interesting because it's one of the very first languages that really ships with a built-in common library. And this has become just a standard. So when you look at modern languages like Go or others, like it has to have a standard library. That's just the way it goes, right? And so I think that what was been missing to enable developer productivity in the Kubernetes landscape is exactly that standard library, is exactly that sort of collection of useful utilities that we can add into all of our programs to make our lives easier. And so that's the kind of thing that I think we need to be thinking about, right? We need to be focused on how do we build up, the equivalent of lists and the equivalent of sorting and the equivalent of the HTTP client in order to target this sort of standard library for the cloud. I think that when we think about how we're going to do this, it's really important to remember a couple of things. That when we're talking to people about modern service development, we're inherently talking to people who are programming in multiple languages. And part of this is just because, we want to be able to target different users, and we want a JavaScript user to get the same utility out of our standard library as a Python user, as a Java user, as a .NET user, as a Golang user, a Rust user. We want all of these people to come together in one community so that we don't have 20 different implementations. We only have a single implementation. But it's also a realization that within any major enterprise or any real medium or to large scale company, different teams are just going to choose to program things in different languages. Maybe it's because you bought a startup. Maybe it's because you brought in an expert who's really familiar in a particular language. Maybe it's because you're licensing a library or a game server and it's only implemented in a particular language. There's a lot of different reasons. You're doing ML, and there's a language associated with the ML community. Python is sort of the de facto language for the ML community. But the truth of the matter is the modern world is polyglot. It's no longer the case that we're having giant zealot wars around like, oh, my language is better than your language and everybody should be using this language or anything else like that. I mean, people still do that because it's fun, I guess. But the truth is that if you're going to be practical about building applications, you should just accept that the world is polyglot, move on and see how we can build things together. I think the other piece of modern service development is that the world is multi-cloud, right? And part of this is because, in many cases, there are regulatory requirements that people be in multiple clouds. Sometimes it's because, you just don't want to be locked in and you want to make sure that you have the ability to move between if you need to. Sometimes it's because you need to be on premise, right? And there's data reasons or governmental reasons, regulatory reasons, or just personal reasons why, you want part of your deployment to be on premise. One of the examples I give from one of our customers is, they're a shipping company. They have boats that go around the world. Well, it's pretty obvious that those boats aren't going to be inside any data centers. But the boat is actually becoming a little mini data center, right? And so those people who we talk to, they want to be able to build applications that run great in Azure and other clouds as well, potentially, but also on their ships, right? And so it's very clear from that whatever we build, if it's truly going to be successful, it has to be able to go to all of these different places. So these are sort of the ground rules, right? That no matter what we do to build out this standard library, we're going to have to build out something that handles polyglot and handles multi-cloud. There's also these business requirements that everybody's operating under, which is, rapid iteration on one hand. You have to be able to push your application every week or every day, certainly not every month, as well as, at the same time, perfect reliability, right? So you have to be able to push code quickly, but you better not break things. I want my bank to release new features. I really don't want my bank's mobile app to go down. Right? And so these two are business requirements that are put onto the programmer that mean in one case we're really, really motivated to adopt libraries and adopt shared implementations because it helps us move more quickly. But on the other hand, we're tempted to not change anything and have really good interfaces so that I don't suddenly, import a new library and with it import a security vulnerability, or with it import performance instability, right? So we need that ability to take on new libraries quickly, but also sort of put them in their box so that they don't affect our running applications, right? We need to be able to limit sort of the blast radius of these libraries that we're bringing in. And those are, if you will, that's the environment in which DAPR was designed, right? And so given those needs around a polyglot framework, multi-cloud, rapid iteration and availability of a library, along with production-grade reliability, all those sort of things came together to form the basis for what we were thinking about when we built DAPR, or the Distributed Application Runtime. And so I'm going to spend the rest of the time talking about DAPR and how it's been designed and how we think it will really help developers meet those business requirements and live in this cloud-native world. So the basic idea to satisfy all of those requirements that we talked through before is the idea of using a sidecar, right? And the reason for this is twofold. The first is that it allows us to have different containers, right? So in this world, we have a user application. It's running inside a container. You have the DAPR co-process. It's also running inside a container. You're talking gRPC or HTTP between them as the language. But what this means, because each piece is in its own container, we can actually put a pretty clean boundary between them. And because the interface that we're talking through is just gRPC or HTTP, it's a pretty thin interface, right? So we don't necessarily have to worry about the DAPR co-process eating up all the CPU that we're using to serve user requests. We can put different C groups, different limits on the DAPR co-process, sort of keep it in its box, keep its memory usage bounded, keep its CPU usage bounded. We can even sort of isolate the file system and things like that using, kernel capabilities to heighten security between these two containers. That's a huge difference from traditional shared library approaches, where you either link it into your application or your application runs in the context of some other platform as a service. DAPR is not trying to do either of those things, right? DAPR is really, as a coprocessor, is trying to be an independent process, but an independent process that is sort of symbiotic with the user's application. Another nice benefit of this is you can easily upgrade or downgrade DAPR without changing your own application, right? So you don't need to recompile your code to get an improved version of DAPR. And indeed, you could have a cluster team that's dedicated to maintaining DAPR that is independent of the application team. And that cluster team that is responsible for DAPR across the entire company could decide to upgrade it or downgrade it without necessarily the user's application even needing to know about that change, right? And so that's a really important piece of it as well, is that separation of concerns. And a real focus of DAPR is separation of concerns, to take things away, to take challenges away from the developer so that they can focus on the core business requirements and allow DAPR to take care of a lot of the details that are oftentimes hard to get right and slow you down from building an application. I want to talk through really the motivations behind what DAPR is. I think, and I'm going to go through sort of a big long list of what DAPR is. One of the most important things, I think, is that DAPR is open source, right? DAPR is an open source project. It's out there on GitHub today. It's really intended to be a standard library for the entire cloud native community, right? And if we can work together to build a great implementation of all of this core functionality that developers need, then we're going to have done a lot to both broaden the tent of people who can build distributed applications, to make it easier for people who already know how to build distributed applications. And finally, we're actually just going to end up building better applications, right? Because if I can spend my time focused on the application and I can reuse a really great implementation of how to talk to Kafka, I'm just going to build a better application because more of my energy is devoted towards uniquely valuable stuff as opposed to reinventing the wheel over and over and over again, right? So we see this throughout computer science, right? The history of computer science is figuring out how to solve a problem really, really well, packaging it up into something that can be reused, and then allowing developers to forget about how it was ever implemented in the first place. Right? I like to point out to people that, while we spend a lot of time in academia learning or in coursework learning how to do something like a sorting algorithm, the truth is that when we actually are programming, the last time anybody implemented a sorting algorithm was probably in a job interview, right? And so it's really important, I think, for everybody that we have these sorts of shared experiences that can bring us all together in distributed systems as well. So we've done this a lot in sort of single process systems. We've done a lot less of it in distributed systems, and DAPR is trying to solve that. It's also really important for me and for the design of DAPR that DAPR be modular, right? And so part of the reason for the sidecar approach is that modularity, so that DAPR can be iteratively adapted. But it's also important that DAPR is modular because if we're talking about a standard library, different people are going to want different pieces of that standard library. And if everybody has to sort of suck in the entirety of a standard library, we're going to have giant containers with lots of memory usage, lots of CPU usage for things that honestly you're not using, right? And so it's really critically important when we were thinking about the design of DAPR. It was really a critical important design consideration that we build it in a modular way so that you only need the pieces, or you only include the pieces that you actually need for your application. And of course, over time, we expect and we hope that, just like Spring or anything else, that people will, use more and more of DAPR, right? That there will be sort of this adoption curve, and actually even that new components will be added over time. But that modularity means that it's on your terms. It's not on, we don't dictate to you, oh, hey, look, we got a new update and it's twice as big and you need to allocate another gigabyte of memory to DAPR. That's really not the focus. The focus is on saying, what do you need? What can we do to help you? Right? In addition to that modularity, or maybe as a part of that modularity, we really intended for DAPR to be legacy compatible, right? And the reason I think about this a lot is because in other systems, especially some platforms as a service, they say, look, we can do all of these things for you, but you need to change all your code, right? And the truth is that that proposition is just a non-starter for a ton of developers and a ton of environments. Right? Like, it's just not feasible to rewrite your application, no matter how awesome the new environment is. Or at least you have to be in a really bad place or doing brand new development for that promise to make sense. And part of the reason why we see applications running on COBOL or running on mainframes that have been around for 40 or 50 years is because of this, right? Because, yeah, obviously you could do a better job running that thing that's running on a PDP-10, running it in Kubernetes. You could absolutely do a better job. Although some people run things in PDP-10 emulators in Kubernetes. But, of course, the act of actually changing that code, not only is it expensive, but it's actually potentially dangerous, right? Because you've got 15 years of mileage on that code that says, well, it works. And so changing it is both an expense, but it's also a real risk, right? And so when we thought about DAPR, we thought, hey, look, we really want to make sure that DAPR is compatible and can be added in as a mix-in, as a sort of spice on the side, as an add-on to any kind of code that is running, right? So we really, while we believe that DAPR is a part of the future and is a part of modern cloud-native application development, it was extremely important to us that DAPR also be compatible with all those legacy applications that you have running in your environments. Because again, the worst thing you can do is build each new application in the latest, newest thing, and have the old environments get left behind. So when you're thinking about how you can augment these existing applications, you can imagine like a classical J2EE application. It's a big chunk of Java middleware. It's talking to a legacy database. Maybe it's SQL Server. Maybe it's MySQL, Postgres, whatever it happens to be. And I realize as I look at my slides here that I said gRPC HTTP. You're not talking gRPC to the database. You're talking whatever the SQL protocol is. Typo, sorry. But with that legacy application and that existing database, you can also very easily add on a DAPR sidecar, right? Or add on a DAPR coprocess to do something new. Maybe let's say you need to, in addition to talking to your database, you want to listen to events from a Kafka queue, right? Well, DAPR knows how to do that and do that in a really great way. If you want to augment your J2EE application to do that, you can just use the DAPR sidecar to do that, right? Or maybe you want to start talking microservices, and you want to figure out how you can expose some microservices from your traditional legacy application so that you can start modernizing and start bringing this app, breaking apart your monolith. DAPR can do that as well, right? DAPR can help you expose gRPC services. It can help you talk to NoSQL storage layers. There's a whole bunch of value that can be delivered, and again, you get to pick and choose, right? It's not like you say, oh, I'm going to now be in the DAPR platform, and that means everything I do has to go through DAPR. No, right? We only want you to come in and use the things that you find most useful. And honestly, if you don't find it useful, then just delete that whole thing and go on your merry way, or find some other way of doing the new application development that you need to do. But of course, we really hope that's not true and believe that there is a lot of value for you in DAPR. All right. I think that when we think about the design considerations, I mentioned that it was polyglot. That sidecar implementation with HTTP or gRPC really is what defines how DAPR can be polyglot. So if all you need to do, in order to talk to DAPR is to be able to use HTTP or use gRPC, well, that's pretty much every modern language out there. Certainly Java, TypeScript, Python, Go, Rust, anything you want to do there. And so when we think about a polyglot environment, the great piece of that is I can actually use Java to talk to a storage layer through DAPR and then read that data through Python or TypeScript or .NET or whatever it happens to be, right? So not only is DAPR building a bigger community by being polyglot, it's actually making it easier for all your polyglot applications to interoperate, because it sort of provides that polyglot translation layer that normalizes everything, right? So it's really focused not just on polyglot for the sense of let developers in any language use DAPR, but also polyglot from the sense of making it easier to interoperate applications built in a variety of different languages. It's also a really important consideration that DAPR be extensible. And we really view DAPR as an evolving standard library. And if you think of every standard library you've ever used, the Java standard library is a great example. Over time, it's grown. There's been the Java process for adding new things to the language as things like OpenGL 3D graphics became important. It was added as non-blocking I/O became clear that it was critical. It was added. All sorts of as concurrency primitives were needed. They were added. All sorts of things were added to the standard library over time, and DAPR is intended to be the same way, right? DAPR defines a whole bunch of things that you can use today, but it's easy to extend DAPR to add new capabilities, right? Because again, that interface between the application process and the coprocessor, it's just HTTP. And you can use that HTTP to do basically whatever you want. Additionally, DAPR defines some common interfaces for storage and other things, and you can provide new implementations of that as well, right? So if you're building some brand new exciting database, or DAPR just happens to not support the database that you're using, it's possible to go into DAPR and add that capability. And now you'll be able to use the same storage interfaces, but with the underlying database that you have already present. I think I mentioned this a little bit earlier, but I wanted to spend a whole slide on this. DAPR is really not intended to be a platform, right? The problem with platform as a service and the problem with traditional platforms is at some point you hit the cliff or the chasm where your application no longer fits in the platform. Every platform that exists out there defines boundaries. This is what we are, this is what we're not. And over time, I think experience has taught us that you hit the edge of those boundaries. You hit the place where your application needs don't match up with the expectations of the developers of the platform. Sometimes in like 12-factor, this is, hey, you know what, I really need state. Or in functions as a service, it might be, hey, I really need to run for longer than 10 minutes, right? When we thought about building DAPR, we thought it was critically important that you never hit those boundaries, right? DAPR is something you add on to your program, but you still control the main. If you want to run for an hour, go nuts. You want to use 10 gigabytes of memory, go nuts. It doesn't really matter to us. We're really a shared library that sits alongside your application, not a platform in which your application runs. And that means there is no cliff. That means that if you need to do something, you can just do it, because we're not paying any attention to what you're doing in your application. We're just sort of sitting on the side like an aide or an assistant who is just waiting there to be asked to do something, or who is delivering messages into you to handle. There is no environment that constrains you in DAPR. And I think that's really, really important, because I think too often when we think about these things, they become these monolithic platforms where you're locked into it, right? And you have to contort yourself into all sorts of weird places to fit your business needs into the constraints of the platform. And I think that's why ultimately people keep coming back to low-level infrastructure primitives like containers or VMs. It's because, platforms are great for a period of time until you get to the cliff, and then jumping that cliff is hard. All right, I want to take a little bit of, hopefully I motivated you sort of for what DAPR is. I want to dive in a little bit deeper and talk to you about sort of how DAPR is built. Give you some ideas about the actual capabilities that are within DAPR. Obviously I mentioned this coprocessor idea. In Kubernetes, we run that as a pod, right? Obviously, you run the application container, you run the DAPR container. They live in a pod together. They share a local host. They talk network. Everybody's happy. But containers aren't the only thing that people use. I know it's shocking for me to say that, but the truth is that there's plenty of applications out there that are running in virtual machines or running on physical machines. And as I said, one of our main goals in the building of DAPR was to be legacy compatible, right? So we really wanted to ensure that you could use DAPR in all those different environments, not just cloud native environments. And so you can actually do the exact same thing with DAPR. There's nothing about DAPR that is container specific. And you can actually run standalone DAPR as a traditional daemon process on a virtual machine with an application process running next to it, right? You don't get some of the benefits of containerization, right? You're not going to necessarily be able to use the same kind of limits to isolate the containers. You don't have a pretty container image that makes it easy to do upgrades. But if you're running in a virtual machine and you want to easily use DAPR and standardize on DAPR for accessing storage or accessing secrets or anything else like that, you can. We're not a platform. We're not going to force you to move to containers just because you want some utility that's in our shared library. We'll tell you why we think containers are useful, make it easy for you to use it with Kubernetes, but it's not a requirement, right? We really want to make sure that DAPR is available to people wherever they are running their applications. I want to take a pause now and show you just how easy it is actually to deploy DAPR to Kubernetes, and how when you deploy DAPR to Kubernetes, it effectively makes it automatic for you to be able to take advantage of the DAPR standard library. So first off, we're going to use the DAPR CLI to install all the DAPR components onto the cluster. And what it's doing right now is it's going out to the cluster that I already have configured with kubectl. It's installing a bunch of components into its own namespace, and then to the DAPR system namespace. And if we take a look, what you can see here is all of those containers are starting to get up and running. So we'll wait for all those containers, and they're all up and running. So now DAPR is installed on my Kubernetes cluster. Now, if we take a look at this deployment here, it's just a simple demo app. But what you're going to see here is I have a couple of annotations. And this one says that I want to enable DAPR, which means that the sidecar is going to get injected. And this one just gives me an ID that uniquely identifies my application in the context of DAPR. So let's go ahead and deploy that. So that deployment has been created, and if we take a look at the pods, what you're going to see here is that there are two pods. In my spec, I only defined one. I only defined this container right here, but it's also added in the sidecar. So the DAPR coprocessor is running as a sidecar next to my main application. And so I hope that shows you just how easy it is to get started with DAPR. And now we're going to take a look at the things that you can do with DAPR. All right, so now we've seen how we can install DAPR in Kubernetes, and we've seen how DAPR adds a sidecar to an application. If we opt into it, it'll add a sidecar to our applications. Now I want to talk about, well, great, you've added that DAPR sidecar. Well, what did you just get? What are the new library things available to you as a developer? What are the building blocks that you have to play around with? The first and most important one, or I don't know if it's the most important, but it's the one that we thought about first, or the problem that we think is in many ways hardest for developers, is storage, right? So, and in particular, in this case, it's NoSQL key value store, right? So, I think a lot of platforms come in and they say, hey, you know what? You shouldn't have storage locally. You should, use cloud storage, do all this sort of thing. But then they say, hey, you know what? Talking to that cloud storage, that's an exercise for the reader. Go figure it out. Go, figure out how to install the Cassandra libraries or the MongoDB libraries. Figure out, exactly how that library was built. Heaven forbid you need to talk to multiple different kinds of stores. You're going to learn multiple different kinds of libraries, different kinds of protocols. Um, it's way too much work for really, honestly, what most developers need, which is, hey, I have a key and I have a value and I'd like to put it somewhere, right? And so DAPR really tries to fix that. And again, reminding everyone that DAPR has this sort of sidecar approach. If you want to store something into DAPR, this is all you need to do, right? You're going to create a post, an HTTP post. You're going to go talk to this URL, and in my store is the name of your sort of is the key that you're using, and then you're going to stringify your object into JSON, or really it doesn't have to be JSON. It can be whatever kind of string blob you want to store there, and fire off that post, and you're done. Right? You have now written a value to a NoSQL store, persisted somewhere, right? And in fact, it could be persisted in MongoDB. It could be persisted in Cosmos DB on Azure. It could be persisted in local running database running on the machine. You don't really, as a developer, care. And this is great also for sort of dev test versus production, because it means that you can write one piece of code and have it talk to a memory database in dev test and a very real cloud scale database like Cosmos in production, right? And again, every language in the world makes it super easy now for you to do a post. No libraries to import, nothing fancy to do, nothing to teach a developer really, because everybody kind of knows how to make web requests. It really simplifies you and allows you to focus on your application and not on the details of how you stored, key value pairs out into the cloud. Again, it also helps with portability because, of course, this the storage can work with cloud storage anywhere. So I hope that gives you a flavor for the simplifications. When we say standard library for cloud native applications, I hope this gives you a flavor for how DAPR is thinking about things. But storage isn't the only problem, and this illustrates. Just gives you a graph. Sorry, I overtalked this slide a little bit. This gives you a graphical illustration of how this works. Of course, storage isn't the only thing. And one of the other really important things that people do with cloud native applications is process events. And when we think about how DAPR makes it easier to process events, it's sort of the same as storage, but in reverse, right? So instead of the application process going to the DAPR process, going to the cloud storage, we have a cloud events thing firing to the DAPR process, which then fires in a simple HTTP request into the application process. Now, it could actually, it's not actually a post. It's not the application making a post. In this case, it's the application exposing a really simple web server, right? And so we flipped around. When we're making calls to storage, we do a web request out. When we're receiving cloud events, we see a web request in. And DAPR has a bunch of different implementations of how you can do eventing or sources for events. And one of those sources is, so Kubernetes has a bunch of different events that occur, whether it's a pod restarting or anything else like that. And you can actually use DAPR to listen to these events. So Kubernetes will fire that event when something happens. That event will be listened for by the DAPR process, which is actually watching the Kubernetes event, API server for events, and then actually firing that event as a HTTP request down into the application process. And I think this really illustrates how DAPR reduces complexity, because of course, learning about how to watch Kubernetes efficiently, learning how to use the client library to do those watches, it's a very complicated thing to do. I know because I've written the client libraries for Java and for others. I've implemented the watch, and I've also seen users struggle with how to use a watch efficiently. And DAPR takes care of all of that for you, right? And so all you have to do is expose a simple web server inside of your application. DAPR will handle all the complexities of talking to Kubernetes, and when an event occurs, it'll fire it down to you. And to illustrate this, this is the code that you need to do here in order to listen to Kubernetes events, right? And if you already have a web server running, like you don't even have to do that, create the web server. You just need to add a new handler, right? And so all we do here is obviously create a new web server. We create a context for this /kube events, and we create a new handler. And then whenever that handler is called, the body is going to be the body of the Kubernetes event, right? And so I think this really illustrates in a nutshell, because the code necessary to do this in Kubernetes natively is quite substantial, right? I think this really does a great job of illustrating how DAPR allows you to simplify and focus on the things that matter to you, e.g. what events are happening, rather than the details of how you actually obtain events from the Kubernetes API server. I'm going to give you a little bit of a demo of this, and you'll see it in action. So what I'm doing right now is I'm saying that I want to use the event component. And what you can see here is I've actually said, OK, the binding that I want for that event component is the kube events binding. And what that means is I'm going to be shipping all of the events that I receive in kube events. I'm going to ship down to a kube events handler. All right. And so if we go over to the code here, actually what you're going to see here is there's that kube events handler right there. And in the code itself, it's actually just a simple HTTP server. And what that's doing is it's going to respond back that it's received the event, and then it's going to read through the event body, the data for the Kubernetes event, and it's just going to write it to system out. All right, so I've built this into a Docker container, and we're going to go ahead and create that Docker container now. So we're going to deploy this Java application out. It's also deploying a role binding and a service account so that the application can have access to the Kubernetes event stream. And now we're going to watch just to make sure that that application gets started. So it's up and running. And now we're going to actually grab it, and we're going to take a look at the logs. And what you can see there in the logs is these are all the events coming in from Kubernetes into that Java application handler that I wrote, that simple web handler, and I'm just printing them out to standard out. But of course, in a real application, you could take that event body and do with it whatever you wanted. So I hope this shows you just how easy it is in a little snippet of code like that to get started with receiving events using the DAPR SIDECAR coprocessor. All right, hopefully you've now seen how we can use DAPR for both storage and for eventing, but there's more that we can do that's useful, and a great example of this is middleware, right? So, an example of what middleware might do is to provide OAuth authentication, right? So we can actually use DAPR to implement OAuth authentication for your application to add authentication without you really needing to do anything to modify the code. Right? So maybe it's because you have a web server that was written a long time ago that you really want to add auth to. You really need to add auth to because you're putting it out on the internet. DAPR can do that for you without you having to change that code at all. Or maybe you just don't want your developers to worry about how to implement this stuff. Or implementing OAuth is not easy, and it's easy to get wrong. And so why force your developers to learn how to do that when really their job is to build a great API, a great web-based API, not to think about authentication. So again, the value of a standard library isn't just that it has a great secure implementation. It's also that it frees up your developers to do things that are focused around the core business proposition that they have, rather than the details of something that is somewhat arcane like OAuth. There's also the ability to interact with secrets. So secrets are kind of like storage, but they're stored in obviously more secure environments like Azure Key Vault, HashiCorp's Vault, many others. You can see here we provide a super easy way to just use the web to access localhost to obtain secrets. And this is great because DAPR is the one that actually knows how to securely talk. Maybe it's through a managed service identity to a secret store. Again, you don't have to teach your developers the best way to talk to the secret stores, the best way to obtain credentials. You just say, hey, hit this URL, you'll get a certificate. DAPR will take care of all the details for you. right? And again, this is the power of a standard library to encode the best practices around token and certificate handling or any kind of secret material handling into a shared implementation, into a community and worldwide developed best implementation, and allow your developers to just focus on their core competency, which is writing the application that uses that secret. All right. Obviously, when we think about these things, we want them to be pluggable and extensible. And when we think about storage or secrets or anything else like that, there's a bunch of different options for those implementations. These are what we call DAPR components. So we have a DAPR interface, which is the storage or secret or events interface. And then we have a component implementation like the Azure Key Vault provider, the HashiCorp Vault provider, Kubernetes secret provider. They all implement the secret interface. And this is what allows us to have a consistent interface from the client side, from the application process, but then the flexibility to target whatever kind of backend you want. I think when we think about DAPR, one of the other really important things is we want developers to be able to use it when they need it, not have to think about how they install it. So DAPR can be installed on a cluster, and then it's activated whenever somebody creates a pod with the right annotation. So it's just an admission controller, and this pattern is used in a variety of places. So a user comes along and says, hey, please create this pod, and they annotate it with the features of DAPR that they want. The DAPR admissions controller sees that annotation, lights up the sidecar, and when the pod is created in Kubernetes, the DAPR sidecar is automatically added. This means then that as an end user, I don't really think about DAPR at all in terms of installing, maintaining, or anything else like that. I just think about the capabilities that it provides me, the simplifications, and how it makes the developing of my application easier. All right, so I hope that's given you a perspective about what DAPR is and how it can make your life easier building applications on Kubernetes or really in any environment. As I mentioned at the beginning, DAPR is an open source project. We're headed towards a 1.0, but we would love your help, whether it's just to use it, give a try, give us some feedback about what works and what doesn't, whether it's to come along and actually add some code and contribute to the project itself. We really want to see and hear from every single one of you, and we think it's a great environment for making it easier to build your distributed systems in Java. Thanks.